Hello and welcome to NCC Group's Cryptopals Guided Tour. My name is Eli, I'll be your guide. In this video, we're going to be looking at Challenge 7 from Set 1, which involves getting AES working in ECB mode. We have a file, which as you can see is quite long and base64 encoded, and we know the key under which this file has been encrypted. Now we need to decrypt it using AES in ECB mode and get the plaintext. Now this is straightforward enough to do. We see here that it is permitted to just import an implementation of AES, which in basically any realistic scenario is what you should want to do. There is value in implementing things like ciphers yourself in order to learn their internals. However, those implementations should never be used in production. You should use something that has been audited by professionals and stood the test of time, which your home implementation almost certainly has not. So if we want to pull in something to compute AES for us, there are a handful of options available to us. We can see this Stack Overflow answer suggesting using the Cryptography library, which certainly does work. Personally, I am not the biggest fan of the API that they provide. I think that these imports are extensive. I think that it should be simpler than this, to be honest with you. But this is one thing you can do. Another option, if you want a pure Python implementation, is to use something like this. You should not use a pure Python implementation. There's no good reason to favor this over something built in, for example, C or Rust. That is simply not justifiable. The performance will be worse. It will not be capable of zeroing sensitive values in memory. It will probably be vulnerable to timing attacks. There will be any number of other issues with it. However, if you did want it, you could write it for yourself and it would look something like this, or you could use this. And I say all of that with all due respect to the author of this file. If you want to implement it for yourself or see how it might be implemented, there is also CryptoHack, which by the way is a very fun site to take a look at, which offers a series of challenges that you can see here that will essentially walk you through the steps involved in implementing AES one at a time, and will have you get hands-on experience with every one of those steps. So that could be valuable if you want to learn the internals of the cipher. We are not going to use any of these solutions. If we scroll down here on Stack Overflow, we see the pycrypto library recommended. Once upon a time, pycrypto was the library to use. As you can see, the API here is much simpler. The imports are much cleaner. The problem with pycrypto is that it is unmaintained, and it has been for quite a while now, close to a decade. And in that time, a number of issues have been identified with it, including a remotely exploitable buffer overflow and heap memory, a problem with the random number generator not managing state properly when you fork multiple processes, and a couple of other issues that are a bit too involved to explain here. The long story short, you should not use pycrypto. However, there is a fork of it called pycryptodome. I'm not quite sure where that name comes from, but I think it's quite cool, to be honest with you. And pycryptodome is absolutely what I prefer to use when I'm writing crypto code in Python, and what I would recommend that you use as well, if you're looking for a recommendation. So we're going to go ahead and bring that in as a dependency for our Cryptopals project here, and that will involve introducing a requirements.txt file. In my opinion, dependency management in Python, I understand that big projects have different requirements than I do, but I personally feel that dependency management in Python went astray when it became any harder than this. Look how easy this is. We're going to create a virtual environment here. What this is basically a localized installation of Python. And when I say localized, I mean localized to this folder. You can see we have a new subfolder here called venv. And when we activate the virtual environment, we can see that we are now inside a Python 3.9 install that is localized to this project. By default, there are no packages installed. However, if we do install-r here, we can see that we now have pycryptodome installed. So let's go ahead and use this to solve this challenge. And of course, we're also going to need base64 decode in order to decode the file that we've been provided with. And of course, the API provided to us by pycryptodome is already fairly straightforward. We're going to make it even easier here by defining a function that just takes a key into ciphertext and returns the corresponding plaintext as bytes. And we indicate that we want to use ECB mode by specifying AES.mode ECB here. We're going to go ahead and read in our input file and then base64 decode it. And of course we know the key, so we can just hard code that here as 8 bytes literal. And now this is so tremendously simple that you might be thinking to yourself, why don't we use this all the time? Before we run this script, let me take a second to show you why we don't do that. This is an illustration of how ECB mode encryption works. As you can see, the block cipher is fed with a key and a plain text block, and subsequent blocks of plain text are encrypted independent of one another. There is no interrelationship between them. This has a number of issues. First off, if one block of plain text is changed, then only the corresponding block of the ciphertext changes, meaning that if you get a ciphertext from before and after a file was edited, it's very easy to determine where the edit was made, which is a non-obvious property that we do not want to have. And it means further that the same plain text block will always encrypt to the same ciphertext block. As we see here, this is an image that's been encrypted under ECB mode, and there is a well-known saying in cryptography. Everyone knows that ECB mode is insecure because you can see the penguin, and this is what that refers to. All right, so if ECB mode is not secure, then what is? That's what we're going to be seeing in the rest of these challenges. Or actually, properly speaking, we're going to be seeing how more secure systems than this also can have problems. But I just think it's valuable to take a quick detour right here at the start to show you how simple solutions are very rarely as effective as they might initially seem on the surface. All right, well, with that out of the way, there we go. We see that we have successfully decrypted this plain text. And we notice a little something at the end here. There are 4 bytes with value 4. You might be wondering what those correspond to. Well, you might just find out in the next challenges, so stick around. Thanks for watching, and I hope you'll join me for the rest of the series.